Panagdaid sa tanan, we will be discussing about components of computers, which is hardware and software. We will discuss more of the parts of the computer and how we can identify each of its parts and how it works. Okay, so by the end of this lesson, we will be able to identify different hardware and software components of computers. You will also be able to recognize the uses of memory, processors, and storage. You will be able to identify or differentiate the types, the input, output, and storage devices. And lastly, you will be able to distinguish system software, application softwares. Okay, so let's start with what is a computer, or how do computers work. So we will watch a video introducing how computers work. So let's watch this video.
Everywhere you look, computers are changing the world. Whether they're on our desktops, in our homes, our pockets, or just about anywhere else. But while most of us use this revolutionary technology daily, we don't often ask, how do computers work? In this series, you're going to learn how computers really work, starting with what makes a computer a computer. Then you'll look at how information is represented inside the computer using tiny electrical signals going on and off at mind-boggling speeds. After that, you'll learn how computers use circuits to do everything from simple math to simulating entire virtual worlds. Next, you'll zoom out and look at the different parts of a computer that actually input, output, and store all that information. Finally, you'll take a look at what code actually is and how software controls hardware. So whether you're just curious about the devices you use every day, or you want to design the innovations of the future, the first step is learning how computers work.
Hi, my name is Lamore Freed, and I'm an engineer here at Adafruit Industries. And this is where I do engineering and design, and I design circuits for fashion and music and technology.
My name is Federico Gomez Suarez, and I'm a software developer with Microsoft Hack for Good. And I look into using technology to help us solve some of the big social problems of our times.
You may have heard that computers work on ones and zeros. Or you may have seen scary-looking visuals like this. But almost nobody today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or a no, true or false, a 1 or a 0, or anything else with only two options. This on-off state of a single wire is called a bit, and it's the smallest piece of information a computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9, and that's how we've all learned to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, A 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, the 4's position, the 8's position, and so on. For example, the number 9 in binary is 1, 0, 0, 1. To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. That's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about other types of information, like text, images, or sound? It turns out that all these things can also be represented with numbers. Think of all the letters in the alphabet. You could assign a number to each letter. A could be 1, B could be 2, and so on. You can then represent any word or paragraph as a sequence of numbers. And as we saw, these numbers can be stored as on or off electrical signals. Every word you see on every web page or your phone is represented using a system like this. Now, let's consider photos, videos, and all the graphics you see on a screen. All of these images are made out of teeny dots called pixels, and each pixel has a color. Each of the colors can be represented with numbers. When you consider that a typical image has millions of these pixels, and a typical video shows 30 images per second, now we're talking about a lot of data here.
Every sound is basically a series of vibrations in the air. Vibrations can be represented graphically as a waveform. Any point on this waveform can be represented by a number. And this way, any sound can be broken down into a series of numbers. If you want higher quality sound, you would pick 32-bit audio over 8-bit audio. More bits means a higher range of numbers.
When you use a computer to write code or make your own app, you're not dealing directly with these ones and zeros, but you will be dealing with images or sound or video. So if you want to understand how computers work on the inside, it all comes down to these simple ones and zeros and the electrical signals in the circuits behind them. They are the backbone of how all computers input, store, process, and output information.
My name is Mei Li Ku, and I'm a designer and an inventor. So some of the things I've designed have been at Apple, and now I design products for kids to use so that they can have an easier time in school. My other jobs include DJing and dancing. Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information.
As the pioneers of computer science explored how to design a thinking machine, they realized that it had to perform 4 different tasks. It would need to take input, store information, process it, and then output the results. Now this might sound simple, but these 4 things are common to all computers. And that's what makes a computer a computer.
The earliest computers were made out of wood and metal, with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine.
Modern computers look nothing like those clunky old machines, but they still do these same 4 things.
First, we're going to talk about input. This is my favorite because what input is the stuff that the world does or that you do that makes the computer do stuff. You can tell a computer what to do with the keyboard, you can tell them what to do with the mouse, the microphone, the camera, and now if you're wearing a computer on your wrist, it might listen to your heartbeat, or in your car, it might be listening to what the car is doing, and a touch screen can actually sense your finger and it takes that as input on what it's doing.
All these different inputs give a computer information which is then stored in memory. A computer's processor takes information from memory, it manipulates it or changes it using an algorithm, which is just a series of commands, and then it sends the processed information back to be stored in memory again. This continues until the processed information is ready to be output. How a computer outputs information depends on what the computer is designed to do. A computer display can show text, photos, videos, or interactive games, even virtual reality. The output of a computer may even include signals to control a robot. And when computers connect over the internet, the output from one computer becomes the input to another, and vice versa.
The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like. My hope is that you get to help decide what you want the computers of tomorrow to look like. But across all computers, regardless of the different types of technology they use, they're always doing the same 4 things. They take in information, they store it as data, they process it, and then they output the results.
Hi, my name's Erica Gomez, and I'm an engineering manager at Amazon.com. One of the best things about working in tech, and at Amazon in particular, is that I get to bring my dog with me to work every day. My job is to help make sure software gets out the door, and her job is to nap under my desk and snore very loudly.
My name is Jerome Holman, and I'm a program manager on Team Xbox, and I have a really fun job, basically bringing the hardware and the software together to give you all the games that you love on your Xbox.
When you look inside a computing device, you see a bunch of circuits, chips, wires, speakers, plugs, and all sorts of other stuff. This is the hardware. But what you don't see is the software. Software is all of the computer programs or code running on this machine. Software can be anything from apps and games to web pages and the data science software that me and my teams use at Amazon to understand how customers behave. But how do the hardware and the software interact with one another? Let's start at looking at a computer's central processing unit, or CPU.
The CPU is the master chip that controls all the other parts of the computer. A CPU needs to do different things, so inside it has smaller, simpler parts that handle specific tasks. It has circuits to do simple math and logic. It has other circuits to send and receive information to and from different parts of the computer. The real magic of the CPU is how it knows which circuits to use and when to use them.
The CPU receives simple commands that tell it which circuit to use to do a specific job. For example, an add command tells the CPU to use its adder circuit to calculate a new number. And then the store command tells the CPU to use a different circuit to save that result into memory. Just like numbers, all of these simple commands can be represented in binary ones and zeros, or on and off electrical signals. The binary commands are stored in memory, and the CPU fetches and executes them in sequence, one after the other. This sequence of commands is in fact a very simple computer program.
Binary code is the most basic form of software, and it controls all the hardware of a computer. These days, nobody writes software in binary. It would take forever. Today, the software we write looks more like this, or even this. Programming languages like these let you type in commands in something that looks a lot like English. To draw a rectangle on the screen, you just need a single command. This high-level command is converted into hundreds or thousands of simpler binary commands that the CPU understands.
Software tells the CPU what to do. But when you're listening to music and browsing the web and chatting with a friend, your computer is running multiple pieces of software all at once. So how do all of these programs get on the computer in the first place? And how can the CPU run them all at once? To find out, we'll have to take a look at the operating system.
The operating system of the computer is the master program that manages how software gets to use the hardware of the computer. For example, I helped create the Windows operating system that runs on most personal computers. The operating system is a program with special abilities that let it control the other software on the computer. It lets you install new programs by loading them into your computer's memory. It decides when a program is run by the central processing unit and whether that program can access the computer's input and output devices. And when you think your computer is running many programs at once, in reality, it's the operating system that's quickly switching between programs, sharing that CPU for fractions of a second.
Inside every computer is an operating system managing software that controls the computer's hardware. The software is a series of commands made of simple binary code, and that binary code is just electrical signals flowing through billions of tiny circuits.
Computers have the potential to do all kinds of amazing things. But the only thing that makes a computer smart or useful is you. When you learn to code, you get to define the problem you want to solve and write the software that turns those ideas into reality. That gives you the power to build things that matter to you, your community, and the world.
Okay. So we will proceed on the next concept, which is the basic types of storage devices. Okay, so we have different types of storage devices. We have the CD or compact disc, DVD, digital versatile disc. We have the Blu-ray disc. We have the memory card. And lastly, the USB stick or the flash drive. Okay, so basically CD, DVD, and Blu-ray disc has like the same usage. So basically they are just different types of disc. And for the memory card, it is a type of flash memory used to store data in digital cameras, while the USB stick is also a data storage device. So you can put different files here in the USB stick or the flash drive. Okay, let's go to the next topic. We have the common computer devices. Okay, so we have the first one, we have the mouse. Okay, so a mouse is an input device that facilitates work with the graphical user interface. So this is what a mouse looks like. Okay, next is we have a trackball. So trackball, unlike a mouse, is not movable. So hand movements are transmitted to the screen by rolling the ball, so which is located in the upper side of the device. Next is the keyboard. So keyboard is used for data entry, issuing commands. So they can be also wired or wireless. We have the next one, scanner. So used to load data, image or text, etc. So it will allow this device to scan an image and make it a file in a computer. Next is a touchpad. So touchpad is used for transmission of hand movement. So unlike working with a mouse, so its user is the one who determines the position of the cursor by touching the touchpad. Next is we have the joystick. So joystick is mainly used in computer games. So unlike a mouse, it has many buttons, but buttons that allows the user to control over game objects. Next is we have the microphone. So microphone is a device that converts sound into electronic signal. So it is also used for communication. So like games, recording a video conferencing. And next is we have the webcam or the web camera. So a camera that stores video signals in a format appropriate for the video transfer over internet in real time. And lastly, the digital camera. So we have the last one. This camera, unlike the analog type, so this one stores photographs in digital format. So this would be the input devices or the common computer devices, which is the input type. Now let's go to the output devices. So next is we have the first one in the output devices is the monitor. So monitor is where you can see the display images from the computer. So it enables us to see the work and the processes that we are doing in a computer. We also have two types of monitor. So the latest type of monitor is the LCD, but not the latest one, but it is the current trend which has the flat screen, like a flat screen, unlike the old monitor which has the cathode ray tube or CRT, which has a big size on the back of the monitor. So this is what the monitor looks like. And we have the second one, which is the projector. So from the word projector, so it is a device used to project an image or project a computer image. The third one is a printer. So we have different kinds of printer, and the most usage of a printer is to print a data from a computer into a paper. So not just in paper, it is also used like for like tarpaulins. So there are a lot of printers, kinds of printers in that is produced. Okay, so example of some examples of different kinds of printer is the dot matrix printer, laser printers, inkjet printer, plotters, and thermal printers, and many more. Okay, and the last one is the speaker. So we have this is like a common device, so a popular output device used with computer systems. So it receives audio input from the computer sound card and produce the audio output in the form of sound waves. So basically it makes the sound of most of the applications, or the applications that you are doing in the computer. Okay, so let's go to classifications of computer. Okay, so the first one here is a personal computer, or a PC. So as the name suggests, personal computer is mostly like a desktop computer. So for those who didn't know what a personal computer looks like, so here it is. The next one would be laptop or tablet, or tablet PC. So this is usually used by individuals who need to travel with a computer. So the difference between the personal computer and the laptop is the laptop is you can bring it when you travel from one place to another. So unlike the personal computer, you can't really use it while traveling. Okay, so it needs an electrical power for it to operate. And next is we have the portable digital devices. So it consists of the PDA, or personal data assistant, the mobile phone, and smartphone. Okay, so there are lots of type of phones, or mobile phones, or mobile like portable devices that we can carry. Okay, let's proceed with the next concept. So the next concept is about the computer system unit. So we will be watching another video about the parts, or the most common parts of a computer in a detailed way. So let's go check what are the common parts of, or what are the parts of a system unit. Okay, so now you know what are the parts of a computer system unit. Okay, so now we will proceed with the computer softwares. So what are or what is a software? Okay, software is called as programs or applications. That is, it is a set of instructions that tells a computer how to perform tasks. So software, unlike the hardware, software is an intangible part of the computer, while the hardware is the parts of the computer is like tangible, so you can touch the things or touch the computer parts. So anything you can touch within the computer is called hardware. So we have two main classifications of a software. So we have the system software and the application software. So let's go first with the system software. So system software is designed to operate computer hardware and to provide a platform for running application software. So basically, system software is an operating system. So usually, the examples of the examples of operating system is Windows, Mac OS. So they are the exact examples of an operating system. So we will be watching another video again, different types of operating system.
Did you know that you and your computer speak different languages? It doesn't speak Spanish, or Swedish, or Chinese. It speaks in ones and zeros. You can't communicate directly with your computer, but that's where your operating system comes in. The operating system, or OS, is the program that lets you interact with your computer. Together, the operating system and computer hardware form a complete system that determines what your computer can do. There are many different operating systems. Two of the most common ones are Microsoft Windows and Mac OS. Windows comes preloaded on most personal computers, while Mac OS runs on all new Macs. Operating systems aren't just for desktop and laptop computers. Mobile devices run mobile operating systems, like Apple iOS or Google Android, which are designed for interactions with smaller touchscreens. Before downloading a new program or application, be aware that it may not be available for your operating system. Some applications work on all devices, while others only work on certain ones. So get to know your operating system to see how it works and what it can do.
Okay, and now you know the different types of operating system or different examples of operating system. So next is we have the application software. So application software are programs that are designed for the end user. So which means this means that the applications that we are using are called application softwares. So example of application software are this one. Okay, so I will be showing you an example here.
If you woke up this morning thanks to the alarm on your smartphone, or if you like watching videos or playing games on your tablet, you're using applications, also known as apps. An app is a software program that lets you do things, for lack of a better word. You'll find apps on all of your devices, including smartphones, tablets, and computers. Some apps help you complete tasks, while others are just for fun. Here are some examples of ways you can use apps. Mobile apps are apps that run on your smartphone or tablet. They can make many things in life more convenient. For instance, if you're looking for a place to buy coffee, an app like Google Maps can determine your current location and then recommend nearby coffee shops. Apps aren't just for mobile devices, though. The programs and applications on your computer can also be considered apps. If you've ever used Microsoft Word to create a document, or a web browser to visit a website or check your email, guess what? You've used an app. Some apps come already installed, but you can easily download or buy more online. Apps are about communication, productivity, entertainment, and more. With so many possibilities, you're sure to find several apps that are perfect for the things you do.
Okay, so basically that's it for our lesson 2. So I hope you understood everything that we have discussed, starting from the input and output devices and from the hardware and software devices. Okay, and also the the important part is what are the parts of a computer, like a full system unit. So I hope you understood everything else in our discussion. So that would be all for our lesson.